In this video, we will look at how to work with grids of positions in Mobius. The pattern.Grid function allows you to generate grids using 4 different methods. Let's have a look at an example, generating a 4x4 grid. In all 4 cases, 16 positions are generated. The only difference is the list data structure. The flat method generates a flat list, with the index ranging from 0 to 15. The rows method generates a list of lists, where each sub-list represents a row positions. The columns method generates a list of lists, where each sub-list represents a column of positions. The last method for the pattern.Grid function is quads. This method generates a list of lists, where each sub-list represents a quadrilateral. In this case, the same positions will appear multiple times in different lists. For example, one of the positions in the middle of the grid will appear in 4 different sub-lists. This is because the position is part of 4 quadrilaterals. Let's start by looking at a grid generated with the rows method. We will assume that the grid is aligned with the global coordinate system. So the rows are aligned with the x-axis. This will make it easier to visualize. However, note that the methods that we describe will work with grids in any orientation. Let's look at how various patterns can be created on such a grid. A range function can be used to select certain rows. Using the start, end, and step parameters allows you to control which lines get selected. In the code, we can see that A for each loop is used to create a series of polylines. Rows can also be converted to columns using the list_zip function. The range function can then be used again, this time to select certain columns. Note that in this example, the same could have been achieved by select columns as the grid generation method. But in other cases, you may be getting your grid from some other source. In such a case, the list_zip can be used to change either from rows to columns, or form columns to rows. Finally, you can also select positions in the grid using 2 range functions. The first range is applied in the y direction to select specific rows. The second range is applied in the x direction to select a specific position in the row. In the code we can see that this is done using 2 nested for each loops. Notice also how positions are extracted out of the list. Since we are working with rows, the order of the indexes is, first y, then x. The y index selects a row. The x index selects one position in the row. Here we can see all 3 patterns combined. In general, these simple techniques can be combined in various ways to create some complex patterns.